Welcome to another episode of Elixir Wizards,
a podcast brought to you by Smart Logic, a custom web and mobile development shop.
This is Season 11, where we're branching out from Elixir to compare notes with experts from other communities.
Hey everyone, I'm Owen Bickford, Senior Developer at Smart Logic.
And I'm Dan Ivovich, Director of Engineering at Smart Logic.
And we're your host for today's episode. For episode 9, we're joined by René Föhring, creator of Credo, and Marc-André LaFortune, head maintainer of the RuboCop AST library. In this episode, we compare static code analysis with Elixir and Ruby. So welcome to the podcast. Before we jump into static code analysis, René, can you tell us a little bit about yourself, where you're coming from, your history in programming?
Yeah, so my name is René. I'm 40 years old, married, have a daughter, and we're living in the countryside in Germany, in the Münsterland. I have used a couple of languages in my career, from Java over C# to Python, Ruby, and Elixir. What brought me to Elixir was a deep desire to learn a new programming language almost 10 years ago. And my friend and mentor, Peter, told me, if you want to learn something really new, you shouldn't learn like Go or Rust, but a functional programming language, because that's a real paradigm shift and you have to modify your thinking around that paradigm. And that's how we landed here. And I'm very fortunate because I code no more in my day job. I wanted to say less and less, but if I'm honest, I'm no longer coding. And coding Elixir in my free time is the great guilty pleasure I have left.
Don't be guilty. All right, Marc-André, same question. Personal history, where are you coming from, programming background?
So I'm French-Canadian, and sadly I'm even older than René. I started programming on Apple II Plus in BASIC way back when. And I did a lot of Ruby, and I've switched to Elixir for the past something like 3 years or so. So
we're going to be comparing notes between Elixir and Ruby. I know the Elixir community has a lot of overlap with Ruby. A lot of, kind of experience learned from Ruby has been brought into Elixir as well. We'll start with René. For anyone who's kind of unfamiliar with static code analysis and kind of the concepts that we'll talk about the tools and the details a little bit later on, but how would you introduce static code analysis to maybe a junior engineer who hasn't crossed this concept before?
So when we are talking about code analysis, there's the difference between static code analysis and dynamic code analysis. Dynamic meaning we are running the program we're analyzing, and static that we are not. And within static code analysis, there are the two big schools. One is we're looking at the source code, which Credo and I think RuboCop does. And there's also a set of tools that looks at object code like Beam files or Java jars. And that's basically it. A static code analysis tool just reads the code.
And so what inspired you to create Credo?
Well, like 8 years ago, there was actually a code analysis tool in Elixir called Dogma, which claimed for itself to be the RuboCop of Elixir. And I was actually, I think until today, the top contributor on that project besides Louis, who was the creator. And so Credo is in that respect standing on the shoulders of giants, because Louis did all the hard work of making the Elixir community accept the fact that we're having some code analysis tool. But much like so many other code analysis tools, they are just screaming results at you, and all of those results are something where you missed the mark. And I wanted to create a tool that was much more lenient in the way that it said, okay, I'm not giving you all the issues unless I run in strict mode, and if I give you an issue, I can also give you an explanation with a code example and some of the rationale behind the issue. So you can feel empowered to say, oh, that isn't really a problem for me. I want to deactivate this check. And that is what mainly motivated me to develop another code analysis tool for Elixir.
Great. And Marc-André, anything you'd like to add around static code analysis or how you got involved in RuboCop?
Well, on my end, I wanted to write a code coverage tool, but that would be a little bit brighter than the one we had in Ruby. The one we had would tell you if a particular line was run when you had all your tests running, but it wouldn't tell you if every single part of your line was actually being run. And to do that, I had to delve into what is Ruby code, what does an AST look like, and RuboCop was the big user of the AST. I mean, it still is. And then I started looking at how RuboCop was doing things. I was like, hey, why are you doing things this way and not this other way? And I started contributing in this way. And I ended up rewriting some of the tools that we use in RuboCop to deal with the AST.
So I'm curious how the nature of Ruby and Elixir, Ruby's object-oriented, maybe hybrid programming language, and then Elixir, which I'm much more familiar with, is primarily functional programming language. How does that affect your approach to building a static code analysis tool? Is it really just I need an AST and then I write messages, or is there a little bit more to it than that?
At some point, I was still contributing to RuboCop and already thinking of jumping on the Elixir band. And one of the big issue in RuboCop is there's many, many checks. I'm very glad that René is focusing on checks that are solid and that people will actually want, because there's so many things in RuboCop that you're like, no, but I really want to write it this way. Stop yelling at me. But there's also a lot of false alarms in RuboCop. And part of it is because, as René explained, when you do static code analysis, you only look at the source code. And it's actually very hard in Ruby to know, and it's actually hard in Elixir also, to know if you're calling a particular function, which function are you actually calling? So, I don't know, if you call the function map, is it the map on an array, for example? Or is it some other, I don't know, a geography-based function where you just want the map of a particular point? And there's actually no really good way to know. So maybe you're in RuboCop and you're thinking, oh, I want to make sure that the users of the map function on array is correct. And you're going to read, oh, I'm calling this function map, and then you're trying to understand what's going on, but maybe it's not the map function that you're thinking about. And I was like, oh my God, I can't wait to see what we can do in Elixir, because in Elixir at compile time, you know exactly which map function you're calling. And naively, I thought, wow, we won't ever have this problem when we do any kind of analysis in Elixir, because we know, are you calling enum.map or some other myGeographyModule.map function? But as it turns out, when you do the type of static text analysis that Credo does, sadly, you don't know which functions you're actually calling. So, and it's just even worse in a way in Elixir, because the way the language is built, you don't know much about anything. As soon as you call use some module, everything else after that, you don't know. Maybe use has been redefined, def has been redefined. That pipe symbol that you see afterwards, it's not a pipe anymore. It's, I don't know, something else. So at least in Ruby, we actually knew when you were defining a class, it had to be a class definition. If you were defining a function, well, it was a function definition. But in Elixir, we don't actually truly really know this. So in a way, I was like very excited that I thought we would be able to have even more powerful tools. And it turns out that Elixir is the way it's built, and with macros in particular, it just means, well, we know even less about what the code really means and what it really is going to be.
I've definitely run into pain points. Macros especially are a little bit overused. I can see this happening, especially with importing functions from another module. I think my personal preference tends to be alias everything and import as little as possible. And that way you get a lot more clarity just as you're working day to day about where things are coming from. But I could also see, now that you're talking about this AST, when you're looking at the AST for a function that's been imported, you no longer know where it came from. Is that kind of like what you're saying there is like, is now a function that's been imported and you don't really have the same level of detail of where it came from?
You don't know which function it is, in a sense that if I do use something, maybe that use does a bunch of imports, and then afterwards I'm calling this function foo. I don't know which module it's from. I mean, when we compile it, Elixir will know exactly which function it is. But if we only look at this particular source code, this just one single file, we don't really know which foo it is. So, and that's trouble.
And I see you nodding, René. So is this a pain point you've experienced working on Credo?
Well, I think it's just something we're sticking with, because there are certainly some challenges which would be easier to solve if we would be looking at the object code, meaning the compiled Beam files. And the most obvious downside from that is that if the code doesn't compile, you're not going to run any kind of analysis. And I'm also not sure if it's in all cases slower, because you have to compile as a first step and then run the analysis on the Beam file. So there is some argument to be made for static analysis and looking at source code, because it's super simple. You can integrate it in other processes. You can write a language server. You can do all those things for interoperability. And I think that's very much an upside you can't ignore. But on the other hand, if you have a put in or map function or something, you don't know where it's imported from. It's just, yep, I'm pretty sure this is a function call and I can't say anything else.
So René, are you seeing, or have you seen in the years working on this, changes in the Elixir language that have helped or hurt this effort?
I wouldn't say that.
Okay.
Neither way. So it's actually that I'm pretty impressed how few changes are necessary to Credo with every minor release of the Elixir language. We're sometimes having things like the new requirement in Elixir 1.16 for negative step functions to be, I can't really remember, explicit or something, where we had to do some backport magic so that we can still support Elixir pre-1.12. But it's also amazing that you don't have to make a major rewrite. So Credo is 8 years old. I'm not even sure which Elixir version was the most current then. I think it was 1.2 or 1.1, something like that. And basically we did not really change that much to keep up with the development. But it's also not like I or anybody responsible was ever super tempted to say, let's throw everything overboard. Let's make Credo 2.0 with no backwards compatibility, because then we can use this new feature from Elixir 1.14 or something like that. And that is also, I think, an interesting aspect, that Elixir in the stewardship that the language receives from Jose and other core maintainers, and how carefully it's evolving is, I think, handed down as a culture to some of its tools.
Yeah.
Great.
I think, so Dan, I know we're both basically web practitioners. We're building web apps. We're not so much working in low-level tooling typically. And I'll come back to that in a minute. But I'm curious, since you've written more Ruby than I have, and I've written a little bit more Elixir, do you have like a favorite RuboCop alert? Favorite in quotes, like one that gets you all the time?
I was going to say the thing I feel like I see most often was going to lead to my kind of the similar question to Marc-André, which is, I feel like the thing RuboCop yells at me the most about is often, the exact point version of Ruby not matching the gem that's installed or what have you, because I believe that the AST, I guess, is either changing so much or whatever makes the Ruby version matter quite a bit to what RuboCop is doing.
Yeah, it's true. I mean, you only get one warning though, and it's
the first thing you see.
They won't complain too much. But it's true. So RuboCop is based on the parser gem from White Quark. So that's not the built-in parser, because there is a built-in parser in Ruby, but it's just not very good. And the White Quark parser is just simply amazing. And they just want to make sure that they get everything completely, totally, perfectly accurate. So even a 0.1 release is going to be like, well, we're not quite sure that we match the AST. But yes, as far as I know, every single release of Ruby, so once a year, there are syntax changes, and those will always have an AST change. And the parser gem aims to be 100% compatible. So it's going to be new nodes or something so that it doesn't, the AST from previous versions for the same code doesn't change. Only the new code that wouldn't even compile in an older version of Ruby will have a new AST. It's 100% compatibility ensured. And it's true that Elixir has been, I've only been here for 3 years, but it's like rock stable on that end. Much easier job.
Oh, and I think back to your question, I feel like the thing I see from both tools probably the most is like just complexity checks.
Bingo. That's the one. You were reading my mind. My favorite, quote unquote, favorite Credo alert or warning is cyclomatic complexity, which, when you're a junior, you're spending like probably 10 minutes on Google, like, what does that mean? But this is one of those rules. So I love Credo. I think we touched on this earlier. It's configurable. We could just turn this alert off and say, I don't care. Things will be as complex as possible. And, don't worry about it, Credo. But I like this warning because it usually forces me to kind of rethink. Usually it's a big cond statement, right? So like in Elixir, we have a few different flow control mechanisms. Cond is kind of like a big if-else branching logic tool. So whenever I've got too many different cases in there, or there's too many kind of and ors, that really blows up the complexity, and Credo likes to tell me that I'm a bad programmer. And that's when I go back and usually the way I solve this is pulling things out into separate functions so I can use pattern matching. René, did you write that check or was that a community contribution? I'm curious if you have some kind of other insights from the tool perspective about cyclomatic complexity.
The point in the very early stages of the Credo project was, for one, to think about which checks I personally really wanted and which were sort of the table stakes. I need this kind of check just to complain about it. And that's the reason why there is a max line length check, and tabs was a spaces check, and the cyclomatic complexity check. I think all of those are very much debatable. The very last community event I went to was a code beam in Amsterdam in the fall of 2019, and I gave a talk that basically started with me complaining that code analysis tools are all garbage and I basically hate them. But one of the reasons why they are all like going on our sanity hard is because we don't use them like tools. We use them like oracles for guidance. Just because there is some check that's always complaining doesn't mean that I'm doing something wrong. I just should take the second and think, oh, I hate this check. It doesn't make any sense for me and my code, and I should just put a general config in my home directory, which disables this for all my Credo projects by default.
I want to say that when I started contributing to RuboCop, does dog fooding. So I think all, if not at least most of the rules of RuboCop are enabled for RuboCop itself. And there was so many times I would be like, oh my God, why is it complaining about the length of this method? Because the length is actually set, in my mind, to something very, very short. And I had to follow the rules because it's not my project. I can't just decide to change the rule or something like that. But I must say that after a while, it actually made me change my style. And I started actually writing more smaller functions and naming them. And I actually started liking the way it read when I was actually reading the code afterwards. Early returns were another thing in RuboCop that I started using. I mean, in Elixir, it doesn't make sense. We don't use that. But I must say I was very skeptical about some of those checks in RuboCop at first. But I think my style improved because I was actually forced to use some of those checks. But I've actually not run into cyclomatic check in Elixir yet, so I'm a bit surprised.
Your control flows must be very pristine then.
I don't think I see it in Elixir as much as Ruby. I think there's something about pattern matching that just lends you to build things in a way where I think you're less likely to do it. But I think in that kind of like early draft of something, you get too many nested conditionals, too many nested case statements, and it'll scream at you. It's kind of one of those things where you're like, okay, I know I'm wrong, but like I'm just going to deal with it for now, and then I'm going to come back and do it. But I think to kind of both your points, like that early feedback, and kind of informing the design, you do end up in a better place. And it's kind of that thing where it can frustrate you, but at the end of the day, it gives you consistency on a project, and it can really kind of help. I was curious if either of you have seen maybe common rules that aren't part of the default set, but you see organizations or projects add on their own often. I know at least there's a plugin system for both, because I think there's lots of plugins for RuboCop to add like RSpec and Cucumber and all sorts of other things. But maybe starting with René, is there something that you see get added to Credo a lot, but isn't in Credo core?
Well, I think if I would see it, I would encourage people to contribute it. But since there is no telemetry in Credo that somehow tells anybody people are using these custom checks, these plugins, these rules, or even this config, so I wouldn't know which are the most disabled checks, which is also the main reason why I am hesitant to, for example, deactivate cyclomatic complexity by default and put it so that it has to be enabled, because you don't know who runs into which predicaments if you just change the default set of checks that are running in preferably a patch version. Yeah, so I think people are building plugins to deliver custom checks to all their projects. That's a discussion I've had on Twitter and GitHub several times. And I guess more people are building small Credo plugins than I would know.
Yeah, I think we see some of these on Hex. So if you or your team builds, and I don't mean like René, you, but I mean like the listener, if you build a custom Credo check and you're like, oh, the world would benefit from this, one option is hex.publish Owen's great Credo checks. Another option is go to Credo, the repo, open a PR, maybe an issue, and discuss with the Credo maintainers, like, should this be part of Credo standard? What's your preference for ideas if people are thinking about checks that they think should be in core? How do you prefer to be approached about those types of ideas?
So there is actually a separate repo for proposals, but it's linked in the main Credo repo when you create an issue. And I think I just want to encourage people to contribute their ideas in form of an issue or a suggestion, a proposal, because I think we have merged many more checks than we have sort of discarded and said, well, thank you, this is useful, I can see it for your organization, but I don't think it's something we should include in the standard Credo set of checks. That has happened, but it has much more often been the case that we slightly modified it to make it more general and then merged it into Credo core, so to speak.
Yeah, I think something as a primarily Elixir developer, something I really appreciate is the language. A lot of the packages that we use, especially the most popular packages, are extensible. So if there's something you want and you can't wait for someone else to build it, you have mechanisms to write a custom Credo check or to extend the functions that are already in place to add a little bit more functionality. So is that something that you can kind of do with RuboCop as well?
There are checks for Rails, RSpec, Cucumber, and it's actually very easy to write your own checks. One of the things that makes it quite easy is that there is some kind of a little bit like a grep, but for AST in RuboCop, which is one of the things that I rewrote in the RuboCop AST. So there's basically a way to say, I want to figure out every single call where a method of this particular name is called with as many arguments as you want, but the second one or the last one must be a literal integer or something like this. To actually do this is very, very simple. In Elixir, it's not so bad because, well, the AST is kind of simple in a way, so you can do pattern match. But one of the issues that the AST is a little bit too low level in a way. So just what I mean by this is, for example, the pipe operator is really just a different way to write a function call, at least in practice. In theory, it could be anything, right? You could redefine it to be anything like you want. But it's kind of a pain that if you want to write, hey, I'm just curious, any call to this particular function with any particular form, you kind of always have to write at least two ways, two pattern matches. One for, is it called with the pipe operator? And another one, is it called without the pipe operator? So there's this cup in Credo that will check if you're calling map and then join, which I always forget that there's map join, so thank you for this check. But that particular check has like 4 different patterns because you can call the map and then you can call the join like with the normal call with parentheses, or you can call the double pipe, or you can pipe the first thing and then not the second one, or pipe the first one and not the second one, which you really shouldn't be doing. But I mean, you can write it this way. And that particular check actually doesn't even check for 4, which would be another way to write your map. And if you imported enum and then you just call map and you call join, that check will also not find it. So you had to write 4 patterns for that particular check, and it catches only a certain percentage of those instances. So that's why what I mean by the AST is kind of low level. It would be really nice to have a little bit higher level, which is here we're calling this function called, map and join. And we don't really care if it was called with a pipe operator or just with a simple dot. But the complexity of actually generating that AST would be pretty big. I mean, maybe we could just eliminate the pipe operator and then, not care about everything else. But there's lots of different issues like this, So,
ooh, you're going to start some drama. We're not going to tell anyone you said get rid of the pipe operator.
Oh, no, sorry.
There will be
That's not what I meant at all. What I meant is the AST generated code that has the pipe operator. Before we want to run it into Credo, for example, it might be a good idea to simplify it, or at least have another version where we're like a semantic AST where we don't have any pipes anymore. They've been replaced by the non-piped version because we want to analyze it on a slightly higher level where we don't really care if you wrote it with a pipe or not. We just want to know what you've called. And ideally, if we could, we could know exactly which function you're calling. Is it enum.map because it was imported, or is it, was it written enum.map, that it would be with all the function calls resolved? But that would imply looking at the beam file. I mean, the complexity of doing that is super, super high. But until we do, then it would be very difficult to have some kind of an easier way to have a pattern match to write custom cups. And then the other thing is, since you both, Dan and Owen, are doing a lot of web, you probably generate a lot of Heeks. And, well, Heeks is not parsed correctly. Not correctly, but it's basically just, we're calling this sigil called capital H, and we have this huge string. And that's it. It's just a string. It's completely unparsed. Where that's not really what we want, right? We would want to have some kind of an AST for the Heeks file so we can actually analyze that if we wanted to. But right now, without any further tools, we just can't do anything with it. So we have to do a grep search if we want to look for anything in particular in a Heeks file, which is, well, not what we want.
So it does seem like the Phoenix HTML library or package has some understanding of HTML structure, because it will report errors whenever you're missing a closing tag, or if you got some incorrect syntax in your HTML inside of a Heeks template. It can support SVGs, other types of markup as well. René, it doesn't seem like Credo really has any understanding of peaks, though. Is that true, or am I way off base with that?
No, that's basically an insufficiency from the very beginning, that we never were able to parse Phoenix's view templates and say, look, we want to be able to provide people with, even for custom checks, give them a way to say we don't want to use this particular helper, maybe even our own, because we did some stupid stuff there and we have to leave the code in, but want to discourage using it on new PRs or something like that. Just because of what Marc-André said. There is no AST representation of it, and it's also funny that in so many domains, the community ends up building sort of alternative AST parsers. So I've seen that in Ruby, I've seen that in TypeScript, and I've also seen that in Elixir.
We're talking about Sorcerer?
Yeah. And I've naturally thought about writing my own, because I'm still an engineer at heart, but then I remembered that I also have a family and a job, and yeah.
You are saying you can't just work 24 hours a day? Okay, well, to each their own, I guess.
Which brings us to the sponsor for this episode.
Right. Energy drink. Unnamed, unpaid sponsorship. Yeah, so I'm glad we're on ASTs. Typically, my work focuses on building features for web applications. Over the past year, I did release a kind of an alternate authentication package. And this summer, I wanted to take a similar approach to the Phoenix auth generator, where you could run a command and generate a bunch of modules and files, so you wouldn't have to hard code all the stuff as a user of this package. So that was, over the summer, that was the first time I was really getting into the weeds with the AST. Before that, it was, it's simple, maybe a little bit in hindsight. I mean, it is a fairly simple data structure, but it is nested data structure. So it can be kind of imposing to look at, especially the first time. I'm kind of curious, and I am using Sorcerer because I think it has some kind of niceties, some kind of helpers there. I think I could probably do most of the things I was doing with the default Elixir standard library now. But are there particular features with Sorcerer that you see as adding value over the standard lib?
If I remember correctly, the first one, which also prompted the creation of Sorcerer, was the inclusion of comments, right?
Right, comments, yes. Yeah, it's aware of when there is a comment in your code, and we're talking about like hash text, outside of the doc tag, essentially. So like you write some notes to yourself, like, hey, I should probably fix this later. Or, Dan, don't worry about this, it's going to be okay. And then you write your messy code. And Sorcerer can actually take that comment, and even after the AST is parsed, it can make sure it lands back in the right spot.
Yeah.
To put it in layman terms.
So one thing that's interesting for me to compare the AST built in Elixir and the wonderful AST that the parser gem generates for Ruby is the AST for Elixir really was built for the compiler. So, for example, comments, we don't care about comments. Let's just discard them because, well, the compiler just ignores them, which makes a lot of sense. And many literals are, their own AST is themselves. So if you have 42, well, the AST is 42. You have an array, well, the AST is going to be that particular array. So function calls are the ones that get modified the most, and tuples, bigger tuples than three or more are also changed. But in Ruby, every single thing is you have an object. That is, you have a node. So it could be an integer node because it's a literal and it's 42. And so you have the value 42, you have the type int, and you have all the source map. So it knows exactly where it started in the code, where it ended. So if you want to go, I was talking about getting higher level than the AST that is generated, but sometimes you want to go lower level. So you want to know exactly how that 42 was written. And in Elixir, there's just no way. So if you wanted to write a check that every single integer that is like a literal integer in the code, if it's higher than 1,000, you want to enforce that there's like underscores for readability. You just can't. You cannot do it currently with Credo or with anything, because when you parse with Elixir, then you only have the integer. So you'd have to check on which line it comes from to figure out exactly how it was written, because you don't know how it was written. Then if on that line there's different instances because someone is writing some kind of tricky code and part of that is in a string, then like good luck figuring out how exactly it was written and where it comes from. In Ruby with this beautiful parser gem, it's trivial. You just look, I have this literal integer. I can check the value. The value is greater than 1,000. Okay, I want to check what's the source. And then you check if the underscores are there where you want them to be. So it's this idea that you want to have an AST to compile the code is one thing, and you want to have the AST to have the complete full picture of what both the source code was like and what it means. That's a completely different thing. Really, we don't have the later in Elixir. It would be really nice if we did, and I think Sorcerer wants to go a little bit in that direction, but we're still pretty far.
Is that possible in Credo? When you get an AST, do you also get kind of the raw string so you could check for the number formatting?
Yeah, so we do actually have that check with the underscores in the numbers, but since we're using some heuristics to determine if we are on, let's say, the right line, and if we are looking at the right occurrence in the text, this check also has a lot of tests that try to minimize the false positives, because it's not like deterministic that we are really looking at the 12,000 that is formatted wrongly.
So are you combining then the AST and the actual file, just text?
Yeah, we're combining, I think, the AST, the token representation, and the binary of the file. So the string, we're making string comparisons, which is like not really super duper good.
I actually didn't know there was this check, and I'm actually impressed you implemented it, because it seems so complicated to do with the current information. I see it's like 250 lines of code. But, kudos. I'm impressed that it exists in Credo.
Well, one thing with these kinds of checks that I try to do is they should, if they're not 100%, they should yield false negatives rather than false positives, because I think people would be much more frustrated by I did not do the thing this is telling me I did. If you had a string where a number is contained and you would complain as a tool, hey, this number is formatted in the wrong way, and you're thinking, gosh, this isn't even a number, how stupid is this tool? Then I would always err on the side of caution and say, let's risk some false negatives but avoid false positives, because I as a programmer would be so annoyed by that.
So kind of carrying on from that then, as far as like frustrating or helping the developer, René, at the top of the episode, you mentioned it's a tool. It's supposed to help you. I was curious if you have thoughts on integrating it into workflow, where you see it fitting, working with like CI integrations. When you say it's a tool, what does that mean to you?
Well, I think it means that it should give people a sense of, for the lack of a better word, empowerment to enforce the rules that are really worth enforcing. Because there are I think there are these effects that Marc-André described when you have a really good code base that is just a bit particular about certain things, and you have to find your footing before it becomes your second nature to write code in a certain way, to structure code in a certain way, then that is at the end of the day probably a net positive. But I've also worked on code bases where there was in my mind a lot of cargo culting. And every time some young IT service firm says, oh yeah, we have a style guide, we just took the Airbnb or the Google style guide, and then we modified it to our liking. And when I was a bit younger and a bit more cynical and not yet a father and did not realize I have to be a role model in certain situations, I always asked the young engineers what the third check from the top of the file does. They enabled so bravely, and most of the time they couldn't tell me what all those checks did. So I think the most important thing is that it's a tool and you have to use it with a goal in mind. I'm not buying a kitchen knife just because if I call in now, I get 3 more for the same price. I buy a knife to cook something, and I should have an idea of what I want to cook. Otherwise, I cannot choose the knife.
Marc-André, do you have anything you'd like to add to that?
I have many knives, actually. And I agree that you want to avoid the frustration of having false positives or anything. There's just like, why? But then again, there's definitely some rules that no one is ever going to agree on, sadly. There was endless discussions with RuboCop about which rules should be. And sometimes I would come in and say, oh, I completely agree with this rule, except it should be reversed. Instead of saying, don't do this, do that, I would say, no, don't do that, do this. Just to show the extent of how difficult it can be to decide which way something can go. I don't know if there's any Credo rules that are like this, actually, where you have to choose which style you prefer.
Yeah, there are a couple of consistency checks where you have to, for the most obvious one, tabs or spaces for indentation. But with the standard set of checks and the fact that people are not happy about 1 or 2 or 3 or all the checks, I'm always reminded about a quote I read from the inventor of C++, who famously said there are 2 kinds of programming languages. Those people complain about and those nobody uses.
Well, and I think that was something I think, and I guess it's the heuristics aspect of Credo that works really well in that, right? Where it's like, it will tell you this is different from how you've done it everywhere else. Not that you must do it one or the other, but it's just like, this stands out. And I think as a developer, especially if you're bringing it to an existing code base, like that's a much more kind of gentle, like, hey, I'm not telling you you're wrong. I'm just telling you were inconsistent. And there's an approach that I think is really nice. And I remember having like warm feelings about that, in early days with Credo.
Yeah, it was also one of those things I could not have forced in the Dogma code base in my mind, because for those checks we have to have a runner that can differentiate between running it on a single file or running it on all the files, because he's looking for consistency. And I think today we even have lowered that barrier. But in the early days, that was something where I really thought, like, I wonder if I can pull this off in a way that's actually usable.
So if I understand correctly, what we should all be doing, all the listeners and all the companies who listen to the podcast should go out and create their own Credo config, like Smart Logic Credo, and then release that so everyone else can cargo cult. That's the point you're making, right?
Yeah, and you should definitely, the first step is to run mix credo -- run. Because I think then you can also get some help around that.
All right, so you heard it here. We're all going to be cargo culting our Credo rules and RuboCop rules. That's 2024. Static code analysis, cargo cult. We'll see who comes out on top.
I hope everyone can hear your sarcasm, Owen. I really do.
What are you talking about? I'm totally serious. All right, I think we are out of time. It's been great analyzing our code and thinking about how these tools actually work. I personally, and I think I can speak for the team I work with as well, like our code base is improved by having these checks, whether we're working in Elixir with Credo or Ruby with RuboCop. Makes you think a little bit more deeply sometimes when you're in a hurry. So I think that's helpful as well. Thank you for your contributions to the community, both of you. Before we go, any final plugs or requests for the audience? We'll start with Marc-André.
No.
Do you need more knives? All right. And then René?
No.
All right. Well, keep your knives to yourself. Thank you both for joining us. And we will be back next week with more Elixir Wizards.
Bye-bye.
Thank you so much.
Elixir Wizards is a production of SmartLogic.
You can find us online at smartlogic.io, and we're at smartlogic on Twitter.
Don't forget to like, subscribe, and leave a review.
This episode was produced and edited by Paloma Pachenik for SmartLogic.
We'll see you next week for more as we branch out from Elixir.
Hey, this is Yair Flicker, president of SmartLogic, the company that brings you this podcast. SmartLogic is a consulting company that helps our clients accelerate the pace of their product development. We build custom software applications for our clients, typically using Phoenix and Elixir, Rails, React, and Flutter for mobile app development. We're always happy to get acquainted, even if there isn't an immediate need or opportunity. And of course, referrals are always greatly appreciated. Please email contact@smartlogic.io to chat. Thanks, and have a great day.